And also, wherever we are unable to capture here, I'm sure learning is like a continuous. So even after this call, I'm sure Moke will make an avenue for us to continue the learning. So I'm just going to share my screen, then kickstart us on the presentation. Okay. See. Don't mind me if I'm a bit too slow. I'm a Microsoft person, not Zoom, but I'll catch up. Uh, okay. See. Okay. I think I have to give Zoom permission. Right. I think I might need to reopen Zoom. Just give me one moment, please. Okay. So guys, confirm if you can see my screen. And we'll get started.
Yep, your screen is up.
All right, cool. Okay, what we'll be talking about today is how we are going to be leveraging microservices architecture to build scalable systems. So let's see what's next. So talking about microservices, so I'll move this one to the side. Right. So talking about microservices, I know we must have heard of monolithic architecture and whatnot. So just to give you a kind of like background as to what monolithic architecture is, look, if you are a backend developer or if you're a front-end developer on this call, I believe you should understand that you've been working with APIs or maybe some kind of repository where you have your backend code and you have your front-end code, right? So, and you also have one domain, let's say API.something Azure website.com. So all of your code is in one place, right? Let's say you have an e-commerce application, your order service, your payment service, everything all in one code. That's basically what we call monoliths. The deployments, everything is handled as a single unit. So talking about monoliths, right? I believe it's something all of us are familiar with here. So there's no way we'll talk about microservices and we won't talk about monoliths. But before I take a deep dive as to what microservices are, I would like us to, go through a short story here. So let's look at the story, the bakery story. So this is Alex, right? Alex owns a small, popular bakery called Alex Delight. And so once upon a time, Alex ran a quaint little bakery. So Alex was a master baker. He's like super talented. He can do almost everything. So he handles everything from baking the bread and cakes to making pastries and cookies and everything you can think of as far as his baking. He even does the customer service. He does the inventory management and just everything, hiring, firing, all of that. Anything that needs to happen in his bakery, he handles all. So now there were some challenges as to the way Alex was doing things, right? So one of the issues was scaling issues. So what do we mean by scaling issues here? Now, because Alex Bakery is popular, right? It was getting a lot of customers. People were buying from him like from time to time. So as the popularity began to grow immensely, he struggled to keep up with the increasing number of orders. Of course, I think if you've been in ShopRite before, you see this small stores that are always outside, maybe the ones that sell shawarma and whatnot. So imagine having like 100, 200 people trying to buy all at once. That means it's going to be a lot of heavy workload on the person who has to like make this. In fact, sometimes you just have to leave because the queue is too long and you cannot wait. So this became an issue for Alex. And of course, Alex, as a business person, he needs to maximize his profit. So now everything became overwhelming and he couldn't handle the request anymore. Then the other issue was rigidity. Now, as new recipes were introduced, right? Now, every new recipe brought about their own complexity. So that made it harder for Alex to manage everything efficiently, right? And also, let's look at the last one, which is like the single point of failure. What we mean here is that now, even with let's remove the fact that the requests were getting heavy. Now, in the case of minimum request, when Alex got sick, right, he couldn't even like deliver anything, even one single request. He couldn't do anything. So that means he has to like take the day off. And taking a day off means money lost, right? So customers will be disappointed, of course, because Alex is like their go-to person, especially when it has to do with bakery. So now let's look at what Alex had to do. Now, sorry, hope I didn't mix that up. Let's skip that part. Okay, I think I skipped one part, so just give me one moment. Okay, now, so Alex thought like, okay, this cannot continue like this. What do I need to do? Then an idea came up. Alex thought like, I think I need to transition into a microservices bakery. So what is Alex talking about here? He mentioned that to transform Alex Delight, that's his business, into a more efficient and scalable operation, he needs to hire specialized bakers for different tasks and revamp the bakery workflow. Now, the first step Alex took was to hire a bread baker. If you guys remember from the start of the story, Alex was the one doing everything. But this time around, he has opted to, hire a bread baker. So Jordan is a bread specialist. He focuses solely on everything that has to do with baking of breads, variety of breads, not just one type of bread. And he ensures that they are fresh and delicious. Then the second person on Alex's hire list was a cake baker, Sam. So Sam, the cake artist, creates stunning and delectable cakes from vanilla to, I know there are some cake lovers on this call. So Sam was striving at that. Then we also have a pastry chef, customer service, and inventory manager. Now, Alex does not need to do all of this anymore. So he has people that are specialized for different things he does in his bakery. So now looking at what Alex has done, what were some benefits Alex derived from what he did? So we mentioned before that one of the issues was scalability. So now with each baker specializing in a specific product, right, it means that Alex can serve more requests, right? And if the demand for bread, for example, increases, Alex can hire another bread baker without even affecting the cake or pastry sections. So now Alex has a bread baker, right? So let's say the request for bread now becomes overwhelming, like really, really overwhelming. He can just decide to hire another bread baker and business will still go on. Now, the issue of rigidity now, for new recipes and seasonal items now, the introduction of them can be smooth, which means, for example, if Taylor can create a new line of holiday pastries without having to like disrupt the baking of bread or the baking of cake, then talking about reliability. See, one thing that we can all agree to is that when it comes to business, you need to like be very, very, very reliable. All right. So with Jordan and the team now, if Jordan is unavailable, right, the cake baker, which is Sam and Taylor, they can continue their own work, which means that we don't have to like close Alex Delight just because Jordan is not available or even Alex himself is not available, right? So if bread is not available today, cake can be available. If cake is not available, pastry can be available, but business must go on, right? Which means even if some customers are disappointed, we still leave other customers happy, pending when we are able to like get back into position. So now, looking at Alex's story, what did we learn here? Now, we understood that initially, Alex was operating a monolithic bakery. Now, from moving to monolithic setup to a specialized microservice approach, Alex Delight became more efficient and scalable, and they were able to like deliver resilient bakery. Now, each specialized baker, that's like the microservices, operates independently, which ensures that the bakery can handle growth, change, and unexpected issues more effectively. Now, with this story, right? I think even without having to like talk about microservices, I think it's simple enough to understand, right, what microservices are all about. I would like you guys' feedback here before I proceed. Is there anybody here confused about the basic concept of microservice with Alex Delight's story? I may not be able to see if anybody's raising their hand up, so Moromoke, you might want to help me here.
All right. Okay, so we have few comments in the chat.
Okay.
This said they can see. I understand perfectly well. Okay. We have few comments that says they understand well.
All right, great. So I just have to take a pause there. I felt, when we are trying to learn anything new, especially when it's like technical, it's always good we use some analogy, and that way we are able to relate it to our real life activities, right? So we don't just, because by the time I take a deep dive now, we start seeing maybe some terms we are not familiar with, and you guys might just wonder like, what is this one talking about? So I think with Alex Delight's story, you guys should understand the basic concept now. So we're just going to proceed from here. So now let's talk about microservices and the concept of software development. So we'll be looking at the definition and some of the key characteristics. Now, what are microservices? Now, we said microservices are independently deployable services modeled around the business domain. If you guys remember Alex Delight, right? The baking of bread, pastries, customer service, those are like the domains of the business, right? Those are like the functional units of the business. So what we just did was we made them independent, right? So with this definition, next time you see what are microservices, you already know what they are talking about. Don't get carried away with all this grammar. Now, we said each service encapsulates specific functionality, like communicating over a network using protocols like REST or messaging queues. Now, this is where the confusion begins. When you see messaging queues, you begin to wonder, okay. But don't worry, as we move on, you get to understand what that means. So let's look at the next thing here. Now, we mentioned we'll be looking at the key characteristics of microservices. Why do we even want to adopt the microservice architecture in the first place? I mean, we had monolith and it was working for us, but let's look at some of the things we get to benefit from it. We talk about loose coupling. Now, when we talk about loose coupling, we mean services are loosely coupled, meaning changes in one service do not require changes in others. Now, if you are a developer in a team, right, and you're working on the same code base, you guys have your backend. I'm not going to like talk much on front end now because microservice is majorly adopted on backend, right? Because at the end of the day, every workload is on the server side rather than the UI. But UI microservice is like a new thing now. It's not something that has been like adopted so much. So let's just take it piece by piece. Now, loose coupling means if developer A is working on a repository for backend, I used our e-commerce example. Let's say you are working for a big organization like InterSwitch now. InterSwitch has a lot of products, right? Don't get it confused. I know they have quick teller payments, they have the quick teller housing and the rest of them, but look at it from this perspective, where we have the payment service from InterSwitch, right? Now, if there are developers that are specialized in payments, they don't need to like share the same repository with the guys that are working on, other products, right? So which means if anything needs to be done on payments, we don't need to like, alter the development or deployment of the other service. So that's basically what we mean by loose coupling. They are not tied together. Independent deployability, it's still like similar to loose coupling. When it's loosely coupled, that means you can deploy them independently. You don't need to like, after making one deployment, then everything goes down based on, okay, let me use this example. We have the payment service, like I said, then we have the housing products. Now, if you make a change in the payment service, you need to redeploy. That means you don't have to like, touch the other services, right? So your deployment is only focused on that particular service that you made your change in. Now, we talk about technology agnostic. So yeah, what we mean is you can use different, for different services, you can use different technologies. Now, there's always a case of, oh, I'm very good at this particular programming language or framework. I do better at this one, or this one tries better than this one. Now, what I'm trying to talk about is if you're building an application, so it depends on the kind of team you have, right? You can have a diverse team where some engineers are specialized in TypeScript, Next.js, Node.js, Express, or whatnot. And some can be specialized in Golang, Gene framework. Now, when we are talking about developing microservices, I don't want us to get it twisted. I don't want us to think in terms of, well, since we have people who are specialized in Gene and people who are specialized in Node, then that means we must go for microservices. That's not the reason why we adopt microservices. The end goal of any system design or architecture is for business, right? So whatever it is we do, if it does not support business goals, scalability, trying to like undo like millions or thousands of requests, then we shouldn't even be thinking about microservice in the first place. But now that we already have that problem, then we have a diverse team, right? Then it only makes sense that I want to consider other variables like, okay, what specialization do we have in our team? Are we a company that focuses on diversity? So if you have engineers that are very good with Gene framework and you have engineers that are very good with Node, that means we can have some services built on Gene and we can have some services built on Node, right? So the guys that are very good with TypeScript and JavaScript, they can be developing the Node service. Let me use my e-commerce application as an example now. Payment service now can be in Java. I mean, people love Java and C# because of their, out of the box security benefit that you get from them. So we can decide, okay, because Java and C# are fast and secure, let's build our payments on C# and Java. Then because Node is extremely fast, let's build, maybe our other processing on Node. Then we'll talk about all of the communication, how everything connects at the end of the day. So that's what we mean by technology and agnostic. You are not tied to one single programming language or framework, meaning, all through our development, we must use Node. No. So you have the benefits of diversity. Then talk about domain-driven design. This is basically what I've been talking about. Microservices are often aligned with business domains. In the case of Alex Delight, I mentioned again, we talked about baking, we talked about customer service and the rest of them, right? So these are different business domains. So there is focus on this, there's focus on that. We are not like trying to, just bring everything as a single unit and create chaos for ourselves. So that is the key characteristics for microservices. Now, we've been talking about microservice a lot, but we don't even know what the architecture of a microservice looks like. Now, this is like the most basic architecture of a microservice. Now, this diagram you see here, I'm going to break it down. Now, but there is one thing I want you guys to know. As you continue in your learning of microservice, you see a lot of architecture. If you look up the likes of Netflix, Amazon, you see the architecture. You just come, wait, but this microservice I was learning is looking different from this. Don't worry, don't bother yourself too much. There is no one fit for all, right? Different business, different adoption and use of technology. In fact, with all of the cloud abstraction we have now, AWS, Microsoft Azure, GCP, all of them have created a lot of abstractions on their environment that allows you to leverage, their cloud product to build whatever it is you want to build. So you might get confused a lot, but don't worry. This is all you need to know to get started with microservice. Now, what we have here, you see, we have for our e-commerce, we have a product service. These are like the business domains. The product service, we have the cart and checkout, we have the pricing and promotions, we have the orders, and the list can go on and on. Now, you'd see that each of these items are connecting to their own database, right? So you see the DB, the data store is connecting to the product. The data store for cart is connecting to cart, the one for pricing, as well as the one for orders. Now, we mentioned something about technology agnostic, which means we don't need to can you guys see my screen, please? Confirm you can see my screen.
Yes, please, your screen is up.
Okay, great. So now, talking about technology agnostic, we don't need to be stuck with one programming language and framework, right? Now, the same concept applies to our data store. Now, for our products, due to the way our data looks, we can decide, we think because of relationships, right, we want to be able to manage our data better, then maybe we can go for MySQL, we can go for MS SQL, or maybe we can go for Postgres, right? Then we can say for things like orders, maybe because we have a lot of orders, or maybe our orders has some kind of semi-structured data, let's just go for MongoDB, because that is basically where MongoDB thrives. All of this are part of system design. You need to think about scalability. You need to think about what your business needs. It's not a case of sentiment. Oh, I like Postgres. Must go for Postgres. So, you need to think of what your data is going to look like. What kind of data are you storing? So others can be talking to MongoDB. Pricing and promotion can be talking to, another kind of data store. Cart and checkout. If you guys are familiar with the concept of chat, or if you've built any chat application before, you must have heard about Firebase. Firebase is also like a data store. So each services, you need to understand what kind of service you're building and what data store fits for that. So now our interaction does not stop there. Now we have the data store and we have the service. Now, all of these business domains that we have, they are, trying to solve only one goal, right? Our e-commerce. We just want to deliver products to customers. Now, you would see that in each of our services, we have a pointer from product, we have a pointer to cart checkout and a linking between them. Then we also have another pointer to pricing and promotions, and we have a pointer to orders. What this is trying to tell us here is that all of these services can communicate, right? It means they can speak to each other. Products can make a request to cart or send some information, retrieve information. So the communication can go in and out, all right? Now, above everything, you see we have something called an API gateway. Now, like I said, right, when you begin to work on microservices, different businesses, different requirements, right? You might work on some products where they don't even introduce API gateways at all, right? Now, don't worry yourself, you're still building microservices, right? Now, but the important reason why we need to have an API gateway, I don't know if you guys are familiar with the concept of rerouting or what's it called? Request forwarding, or I'm trying to remember the reverse proxy, all right? So now this API gateway, the reason why we use it here, as some would say, some call it backend for front end, all right? Now, what API gateway is just doing is that it's saying, now, for me to deliver to the client, that is the front end, we call the front end client, or the mobile app, or maybe it could even be a desktop application. Whatever it is that is going to consume our API, those are our clients, all right? Now, the API gateway is like a middleman here. Now, the main reason we have API gateway is to keep things simple, clean, nice, and maintainable. You know, as a software engineer, the first thing they will always tell you is write clean code, maintainable code, reusable, and all of those things. So if you're not following this concept through, then that means you're doing something wrong. All right. So now this API gateway is supposed to like help us do a kind of request forwarding. Now, if we have product service, right, it only makes sense that when we are deploying our product service, it's going to be like maybe API.products.something something. That means the domain is different, right? Then for CAT, the domain is also going to be different. Now, when the front-end person needs to integrate our APIs, they would ask for the base URL and, you know, the API endpoint. Now, that's going to create an headache for the front end, right? Because now they have to deal with multiple URLs, right? They have to manage all of that. Then what happens maybe in the future, we have like 10, 15 microservices. Then we want the front end to manage all of those information. That is just kind of nasty, right? It's not, it doesn't support a scalable design. So what API Gateway does is that it can help us achieve a single base URL, right? Now, if we have like a request that we're supposed to send to product service, maybe it's like product slash this slash that, right? All we need to do is to get the endpoint, register it in our API gateway. There are different tools we can use for API gateway. For the guys that are familiar with Microsoft Azure Cloud, you can use Azure API gateway. If you are a .NET person, you can use Ocelot. If you are a Node kind of person, you should be familiar with Nginx. You can even use Nginx for .NET. You can use it for anything and a lot. But the important thing we need to understand here is when we are setting up API gateway, we have something called upstream and downstream, right? So all we need to do is just make sure that the domain is pointing to a kind of uniform domain, right? So all the front end needs is API slash dot gateway slash maybe product slash orders. The front end does not need to know the main domain for product, the main domain for cart, and the rest of them. So all of that is encapsulated. So when we send requests to the API gateway will find the downstream part, send the request, and return the request back to the client. I think that's like simple enough for us to understand. So that's basically what this architecture is talking about, right? So I'm going to proceed now. Please, let's make sure we are maybe putting down questions just in case. I would have liked to like ask questions now, but I don't want to disrupt the flow. So we mentioned about some of the characteristics of microservices. So why adopt microservices? We talked about that, but let's look at the core benefits of microservices. Now, we said some of the benefits of microservice include flexibility and agility. We talked about flexibility before. We talked about not being constrained to one technology stack. We talk about faster time to market. Smaller independent teams can work on different services. So it means that when we have maybe new feature developments or, we need to see at the end of the day, the main goal is to deliver value, right, to customers. So if we have people working on this and other people working on the other one at the same time, then we can deliver to the to customers as quick as possible. They talk about scalability, which is like the whole which encapsulates like the whole concept of why we are adopting microservices in the first place. We talk about individual services can be scaled independently based on demand, optimizing resource use and cost efficiency. I'll talk about some of those later. We talk about Cohen's law. Microservices, the system design mirrors the organization communication structure, enhancing team autonomy and productivity. All of this we've talked about before. All these ones are just English, right? Enhanced maintainability. I've talked about deployment, making changes without constraining the other services. You just stick to the main thing you're developing at that point in time. We talk about fault isolation. You can treat each services, handle faults, the other services don't need to know about what's going on in a specific service. All of this we've talked about. So let's proceed. Now, here we look at strategies to ensure all the grammar we'll be talking about: scalability, reliability. Now we know what microservices are. How do we strategize to make sure we are designing a proper microservice? So let's look at that here. Now, for the first one, which is scalability, now we talk about horizontal scaling. Now, you might be hearing that for the first time, but it's okay. Now, what horizontal scaling means is that we can scale out by adding more instances to a microservice rather than scaling up by increasing the size of a single instance. Now, you see in my diagram here, I also have vertical scaling. Now, if you are familiar at all with system design, in vertical scaling, what we mean is that if you have an application that you have deployed, let's say you deploy to Microsoft Azure, right? For example, sometimes they give you options to choose maybe like a basic instance or maybe like a standard plan, and whatnot, right? Now, what they are basically giving you is resources, computing power, right? Now, think of it, right? When we're talking about cloud, I need us to I'm saying this because of people that may not be familiar with cloud. I want to make sure everybody's carried along. Now, if you're familiar with on-prem servers, right? For on-prem servers, think about hosting an application on your own computer, right? That means if you have like a Windows machine, and on your Windows machine, you have like maybe 1 terabyte of storage, right? You can save a lot of things, right? Now, when your memory gets to 999 gig, now you're in trouble because you need to maybe delete some resources, or maybe you need to like scale it up. You go to meet the engineer and say, Mr. Victor, say, I think I need 2 terabytes. So this 1 terabyte is not going to work for me again. That is basically you scaling. So don't get carried away by all this grammar. Like I said before, you are just scaling. Now, so when we deploy our application, right, we are basically using computing resources. We have like storage for files, we have storage for this and that, right? Now, when we begin to consume a lot of memory, our application can slow down, right? Which means the performance can be impacted. I was talking to one engineer the last time, I was seeing a lot of for loop in our code, and I asked like, what do you know the impact of this kind of code you're writing? You know, I don't know if she's on this call, but now the whole point of that is that when we develop our code, right, sometimes we make mistakes because we don't know the performance implication of what we are doing. Our own is just, if it's working, leave it, don't touch it. But we are using a lot. I don't know if you guys are even familiar with asynchronous programming at all, where we try to leverage the CPU power to do multi-threading. The CPU is very powerful, which means that it's not constrained to one single operation at a time, right? It can perform multiple operations at a go. So, but when you are doing this, right? Okay, let me use another analogy. I don't like to confuse people. Now, think of when you open Chrome tabs, maybe you open like 10 Chrome tabs, right? The next thing you see, your system will start to hang. You get frustrated. You might just switch it off, and turn it back. Sometimes it will not even respond again. That is because your CPU has been clogged, right? You are doing so much operation, and now, in fact, it will even tell you out of memory for people that are still using like 1990 PC. So these are some of the things we don't want to encounter. Then maybe when you're not trying to access the application, you see server down or something like that. We don't want that to happen. So in our microservice, we adopt the concept of horizontal scaling. Why? Because we feel instead of adding more CPU power, which is like the vertical scaling, adding more memory, right? We want to scale horizontally. Now, we may not really understand how that horizontal scaling works, but I will still explain later. But think of it as provisioning multiple instances, even for a single microservice. Now, let's say, you remember we mentioned our products, we mentioned orders, right? Now, let's say for orders, right? If you are, an e-commerce, you guys can think of like Jumia. Imagine how many orders Jumia process in a day, right? So if you are getting a lot of orders and it's impacting the performance of the app, Jumia can decide and say, okay, you know what? Let's have another order microservice. it's like a replication of that particular service, right? It's still working the same, but I know now we must be wondering, okay, if you create multiple instances of a single service, how is that going to work now? How will requests be sent if you are using two services? All of that we'll talk about. And that is where this guy we call load balancer comes in. We're still talking about scalability. Now let's talk about load balancing. Load balancing, yeah, we distribute traffic across multiple instances of microservices using load balancers to prevent any single instance from becoming a bottleneck. So now load balancer is like a kind of architecture that allows requests to be forwarded to multiple instances of a single service. Now, I'm not going to go deep into load balancer because that's not the reason why we're here. Now, but I'm going to explain the basic concept of it. Now we have our inventory service, right? Inventory is getting a lot of requests, right? And there is a certain threshold that once inventory reaches like this, is dead. Now, our load balancer can strategically, see how inventory is doing. Once it sees that inventory is not doing well, then it can just forward the request to the other instance of inventory. It is still working the same. Nothing has changed. The data store is not changing. It's still talking to the same data store. It's just a replication. All right. Now, but with this concept, we don't use it only for issues of maybe one service is getting overloaded. We also use it for regional scalability, right? What I mean by that is that if you are in Nigeria and you are making a request to a service that is in countries that is like thousands and thousands of miles away, it's going to be slower, right? Compared to making that request in the way I see it, when you're making, that's why you should appreciate Google a lot. Google is doing so much. The fact that you can access the website, everything is so fast. That is a lot of work that has been done. So if you guys are also familiar with cloud, you see they say a lot of things about data replication. Azure regions has a lot of, we have the South Africa region, we have the reason why they do all of this is that they want to make sure that data centers are available in zones that are close to you. And that is the strategy they are using to serve us well, right? Because if the data center is very far from you, that means your request will be slow. So that way they have achieved scalability by duplicating the instance of a service to make sure that it gets close to you enough so that your request won't be like super slow and all of that. So we use load balancer to achieve this kind of thing. So I'm going to move to the next one. Here we talk about reliability. Now, when we are talking about scalability, the main purpose of everything is having a reliable system, right? We want to serve customers, we want to make sure we are not having downtime. I mean, when we begin to have downtime and our services are struggling, customers begin to lose faith. Like, looks like these people don't know what they are doing again. You get frustrated, especially if you are like a big business that has like a serious competitor. The moment you disappoint the first time, you disappoint the second time, I go to your competitor before you see me again. Like your people will say, Alola. So you want to make sure that your service, your uptime is excellent, right? And that is the purpose of why we are here. Now, we talk about for us to achieve reliability, what is the strategy that we know that we can use? We can use circuit breaker pattern. Now, circuit breakers help us to prevent cascading failures by stopping calls to a failing service after a threshold is reached. Now, think of this, try to relate this with load balancer that I just explained. So circuit breaker is just like a design pattern that helps us to achieve what that load balancer is doing, right? So I don't want to go into that as well. Now, this is what a basic architecture of what circuit breaker design pattern would look like. So it has a concept of closed, half open, and open. Now, I'm just going to explain how that works. Now, when the state is enclosed, right, of an instance, it means that it is ready to receive requests, it is doing very well, right? There's nothing wrong with that instance. We don't need to like start forwarding requests to another instance. The instance is LD. Now, when the instance is half open, it means that, okay, some requests are beginning to fail, right? Okay, if you are using AWS, you can do some of this configuration to suit your own needs. Maybe you can say, once I have like 5 timeouts, please route the request to another service, another instance, right? You can, configure all of that the way you want. Now, for this, once it's half open, it means some requests are beginning to fail, right? Now, if it reaches that threshold where requests keep failing, right, then it goes from half open to open, which means this service is not LD at all, right? So there is no need routing request to it. So we route the request to another instance. This is what circuit breaker helps us to achieve. Now, later on, it will pull that instance again and see if it's LD. It can now move it to half open. Then if it sees that, okay, the instance is behaving well, that means the service is LD, then we spin it back up and everything becomes normal again. Then we'll talk about health monitoring. So to achieve reliability, we also need to make sure we are monitoring the health of these services, right? Know which service is down at what time. Do we need to spin up another instance? And all of those, right? You can achieve by, making sure you have all your configurations done. Now let's look at the next thing. Here we talk about maintainability, right? Now, no matter all the sweet, beautiful things we do, if we don't maintain, then there's going to be a problem, right? Now, we talk about service registry. When you use the service registry, you can keep track of service instances, just what I explained earlier. You can keep a track of locations, you can also enable discovery and management of services. Now, this is like a core concept, right? When you begin to work with microservices, the main purpose of service, your life is fine, trust me. You'd see in that basic architecture I showed you, there was no service registry here. But in this case now, we see that the service registry in this architecture is communicating with the gateway, right? What this just does is that it helps each of your microservices to register themselves, right? You can maybe send a registration request to your AWS service that does this for you to make sure that product, shopping cart, pricing, order, all of those services are registered. So if one service is not LD, you can discover it from that service registry, right? This is like a core concept. You don't need to worry yourself about it now. Now, let's look at centralized logging and tracing, right? Now, when we are developing our application, it's either we do database logging, we do file logging, whichever one works for us, right? But now we are dealing with multiple services. We have product. Do we want product to have its own logs? We have shopping cart. Oh God, it's really, really a lot of work, especially if you have like a large team managing your microservice. Oh, something is failing. Oh, we need you to go and check the logs for a particular. It's really, really stressful. This is where we have a centralized logging. A centralized logging is just an architecture that allows you to encapsulate all of your services. Now, each of your services, product, shopping cart, pricing, and the rest of it, all their logs will be collected into one single service, right? That service is uses Elasticsearch, right? Elasticsearch will store everything in a central place, right? Then we have a tool called Kibana. There are other tools you can use, right? So Kibana is like a UI for, visualizing logs. You can see what is failing. You can filter. I've used Kibana before, and trust me, it's a very, very interesting tool. But a lot of organizations would not even want to use it. So you might end up doing login, doing your login check for each of your services. Or better still, some organizations, if they don't want to use Kibana, maybe because it's expensive for them, what they do is just maybe use like a central service. Maybe you can call it a database, audit and login service. You can even spin it up as a microservice, right? But how interaction is going to work, how you're going to be like sending the logs, I will explain that later. So this is just what we are talking about here. We want to make sure that we can monitor everything in one place. We don't want to go and check this log, go and check that log. Just let me filter. And, at the end of the day, right, the main reason why we are going with this architecture is to deliver value, right? So if we are saying we are delivering value, and at the end of the day, we are still creating constraints for ourselves, then that means what we are doing, it needs to be like reviewed again, right? It means there's something we are not doing right. So imagine we want to deliver value, and just to trace login and what is failing, it's taking us like forever. So what's the point of everything at the end of the day? So you want to make sure that to build a proper microservice, you have a centralized login and tracing. So let's look at the next thing for us. Now we understand some of the strategy, right? When designing microservice, you need to make sure you follow through everything that has been said. Now, when we want to design our microservice, we need to consider domain-driven design, DDD. It's something you might have heard of before. Now, let's go back to our story of Alex Delight, where we mentioned, we need to make sure we have somebody specialized in bread baking. We have somebody to, manage customer service and all of that. Each of those single things are like the domains of the business. They make up the business, right? Now, if we are designing a microservice and we are not following through with the architecture, then that means we are doing something wrong, right? Now, the concept helps us to align microservice with business domain to ensure that they encapsulate specific business capabilities. Now, let's not even talk about microservice. Even in our normal monolithic architecture that we are familiar with, I still see developers make a lot of mistakes. You call something a product service, right? If you guys are familiar with, some basic design patterns, right? There is this thing you always want to do. If you are following the repository pattern, you want to have like maybe product repository, you have order repository, payment repository. Then you see developers, they will carry the function of order inside of payments. You just kind of mix things up. Right? Then at the end of the day, they will now be having like a kind of circular dependency. It's garbage. I have to tell you guys, it's total garbage. So you need to make sure you understand how you are constraining the boundaries of each of the services. If you call something a product service, let it be product service. If it's payment service, let it be payment service, right? At the end of the day, you have a controller where you can call each of those services and do whatever it is you want to do and deliver value. Now, this is what we mean by bounded context. Define clear boundaries. Now, look, it's just like you are in Alex Delight now. Now, Alex comes today and say, what's that guy's name that bakes bread again? Then you tell the guy to start baking cake, or maybe not even bake cake, maybe begin to do some of the things that the cake baker would do. That will create problems, right? Because at the end of the day, he might not even do it well. Then that's going to create some conflict, right? Because now Alex, Sam, or whoever that big bread baker is getting confused as to what exactly his job is, right? Then the other one too, he gets confused. Okay, this guy is doing it. Maybe I'm not the one to do it again. He just kind of mess everything up. So you need to make sure that the boundaries are well defined, right? You are not giving one responsibility of a service to another service. That is not microservice at all, right? Let's look at the next thing. Now we talk about service boundaries, right? Now this is basically similar to what I just explained. And when we talk about single responsibility principles, each service should handle one specific part of the business logic. Now, we are saying we are designing a microservice. Then next thing, we moved authentication service, right? I mean, we need to make sure users are secured. Then we move authentication service and payment service and call it a single microservice. In fact, without having to even worry about the microservice architecture, let's use our common sense. What name are we going to call that? Are we going to call it auth payments? It doesn't make sense, right? So you need to make sure that if you define a specific domain, make sure it focuses on that thing you want it to do. Not like it's doing three things. You're not designing microservice, right? Now, we talk about business logic encapsulation. Services should encapsulate business rules and logic related to that domain. I think that's like very straightforward. Now, you see in this diagram, we have this one not accepted and this one is accepted. Now, I wish I could call out some organizations, to be honest. I've worked an experienced situation where an organization says they want to design a microservice. Next thing, we have database calling another database. If you are familiar with the concept of stored procedures, if you write a lot of SQL queries, then you now do join from one database to another database. I'll just be like, you know what? Just design your monoliths. Now, there's another problem. People make the mistake of calling a distributed monolith, calling it microservice. Please, friends, it's not the same. Microservice is not just about separation alone. Because you have separated things now does not mean you have designed it. No, it goes beyond that, right? But I've seen a case where an organization is using one single database and multiple services. I said, you know what? Carry on. As a developer, when I'm working on such products, right, I even get discouraged because I feel like I'm doing rubbish. But if that's what they want, I need my payday. Of course, I have to follow through. So this is not a microservice, all right? You don't want your data stores talking to each other. They have no business. They shouldn't even know about each other. The BA and the BB should not know about the existence of each other. What we have is the inter-service communication. Payment service talks to its own DB. Other service talks to its own DB. Then they meet at the front to communicate whenever they need to. So always make sure you define the service boundary. Then next, we have APIs and communication. Remember, guys, I told you I was going to tell you about the communication part. We'll be talking about the services, this and that. But how exactly do this service communicate? Now, let's look at it from this concept. A customer logs in to our e-commerce application and say, okay, I want to buy a bag, right? So the first step will be, I'm checking the product section, right? I'm interacting with the product service. I'm checking the products. I see the catalog. Oh, all right, I select this one. The moment I select this one, I have to cart. Maybe we could have like a cart service handling that, right? Okay, now I have my product in cart. Now, how is that communication going to happen from product service to cart service? That is where we have synchronous communication or asynchronous communication. I hope you guys can still hear me. Let me be sure I'm not talking. Great. Now,
yes, please.
What we mean by synchronous and asynchronous, I'm going to explain that. Now, when it comes to API communication, there are different protocols we can go with. We can go with RESTful APIs. We can go with asynchronous communication. We can go with gRPC, whichever one the business will serve the business well. Now, let's talk about RESTful APIs. We are all, if you're a developer, you definitely know what a RESTful API is, right? So for synchronous communication, what we mean is that when I'm making a communication, right, I need my response immediately, right? Once I make the request, I must wait to get and that is what this wait means. I must wait until my response get delivered. So for example, now, when I click on add to cart, the moment I click on it, now my product service will send a request to my cart service and say, oh, Mr. A is trying to like add something to his cart. Then cart service will now tell me, sorry, I couldn't add that item to the cart. Something went wrong. Oh, I've added the item to cart. I must receive that response. That is basically what a synchronous communication is. That simple. You must give me that response immediately. If you don't give me the response, I'm not going anywhere. So I must get a failure or success response. That's synchronous. Now, for that, we use RESTful API. You could, if you're familiar, you'd see things like HTTP clients, Axios. For the guys that consume APIs a lot, you create an instance of Axios, the Axios.put.get and whatnot. What you are basically doing is making a synchronous communication to another service, right? Even for front-end guys, that's what you're doing, right? So you're using RESTful API for communication. Now, what are some of the bottlenecks with this? Now, if you are making a request and you say, by fire, by force, you must get your response. There's a problem with that, right? Now, we did talk about some of the things that can go wrong with your services. Now, you make a request to CAT service. CAT service is having issues at that point in time. It's either you keep getting errors, like, sorry, unable to process your request, sorry, unable to process your request. That means you are stressing the customer. It's either the customer waits there and starts tapping, what's wrong? Click again. That's a shit experience, right? We don't want that to happen to our customers, right? Now, it doesn't mean the synchronous communication in its real sense is bad. It's not bad, but we are just considering scalability. Then let's even say the CAT service is LD, anything can go wrong. We are Nigerians, right? If you are a loyal customer to Glo, sorry, Glo, if you are loyal to Glo, you can just make a request and fiam, your internet is just disconnected at that point in time. That means your request will not be fulfilled, right? Something can go wrong with your request. It can stop halfway. It could even be that the request was successful, but maybe on trying to deliver the response, something went wrong and you couldn't get that response. So now, because of these kind of issues that can happen, right, when it comes to network connectivity, especially maybe the load, let's say your request you are sending, it even contains files, and files will contribute to your stream content, which means you can be sending like kilobytes or megabytes of data over the network, right? That's a lot of problem, right? So things can get disconnected. A lot of problems can happen. And because of that, we introduced a lot of strategies. Maybe we introduced retry. In fact, I don't know if you guys, maybe you've experienced a situation whereby you try making a payment online, you were debited twice. For example, now, maybe you make a payment initially, you didn't see any response, right? Maybe you now felt, this thing, maybe I didn't click it correctly. Then you click it again. Well, the next thing, double debits. So you would see that Nigerian banks now are improving. Before, they used to be like embarrassing like that, but they've improved a lot. You see now, the likes of Fidelity, when you try their app, when you send a request, if the thing does not give you response immediately, right? When you now try to make another payment, they will tell you duplicate transaction. Is to say, that means what you did initially has not been fully processed. So we don't want you to lose another money before you start disturbing our customer service and insulting them. So these are some of the things they try to do to mitigate the impact of synchronous communication, right? Now, let's look at asynchronous. The only difference is the A behind it. And trust me, there's nothing so big. Now, in the concept of asynchronous communication, we use things like message broker. Now, what we mean here is that we have the likes of tools like RabbitMQ, Apache Kafka. We have, all of this. This is just to make sure we have a resilient communication when we are doing inter-service calls, right? Now, what asynchronous means is that, look, I'm going to send you a request. It's okay if you're not feeling fine at the moment. When you're feeling fine, deliver my response, okay? So what it means is we are not waiting for the response immediately, right? We are saying, whatever it is, take it, right? In your own good time, process the request as you need to process it. But now, looking at these two concepts, we'll be thinking, so when do we now decide if I send a request, I want to get my response immediately, right? So I can't say, give me feedback whenever. It doesn't make sense, right? If you make payments, you want your response immediately. Good. These are some of the things we need to think about when we are adopting whether a synchronous or asynchronous communication. Now, where do we mostly use asynchronous communication? We use it mostly when we don't want an immediate response. I'll use an example. When a customer makes a request or makes a purchase, right? After making the purchase, it only makes sense we send a notification to them, right? Say, maybe send an email. Thank you very much for your purchase. This is your receipt. How many things will go underground for you to generate a receipt. You call this service will call that, you could even be retrying something in the background. Now, we use things like asynchronous communication. Why? Because emails can be delivered anytime. All right. Yes, we want it to be quick, but we don't have to wait and, just send the email when you're ready. But for other operations we do, right, where we need feedback because the feedback will determine the next action we are taking. Then we want to make sure we are using synchronous communication. But there is also a way to balance things that you can still use asynchronous communication in the context of synchronous. But before you do that, make sure you understand exactly what you are trying to achieve. I won't go deep into that, but the tools like RabbitMQ use PubSub architecture. All PubSub means that there is a concept of a publisher and there is concept of a subscriber. So what you are just doing here is before you can start doing inter-service communication in terms of asynchronous communication, you need to have a publisher. So a publisher is the one that will send the message. I will mention another benefit of asynchronous communication. A publisher is the one sending the message, which means in our case, product service is the one sending the message. Then product service will be the publisher. While the card service will be the subscriber, which means that card service needs to be listening to events that will happen on product service, right? Which means whenever we have something to deliver, card service should be ready to pick it up immediately, right? Now, the other benefit of asynchronous communication now think of a case whereby you need to speak to multiple microservices at once, right? This service needs to speak to this service and that other service. For example, now, product service needs to send a message to card service saying, oh, somebody is trying to add an item to another, right? Maybe when a customer is trying to make that initiation, we want to log or audit that activity that, oh, a customer just made a request, right? Now, that means product service might need to make a two-way communication. It needs to send message to notification service that, hey, somebody is trying to add to cart, or you could even delegate that action to, cart service. But the point here is that there are two-way communication happening at once. In that context, it's better we use an asynchronous communication. When you begin to use tools like RabbitMQ, you see things like fan-out exchange, where we use concepts like queues, right? Queues are just like, they are just like we call them messaging queue, right? So each services can subscribe to that queue. You can have multiple queues, right? So it means that whatever service is subscribed to that queue, whenever a message is delivered to that queue, then each of those services will pick it up and process what they need to process. And what is the message? It's just JSON objects that is stringified. So you just stringify it. When you receive it from the queue, you deserialize it and you process it. If you have worked with jobs, maybe all this background service is just similar to what it does. In fact, when you begin to implement this asynchronous communication, you will see some concept of background service there. It's just background task that is encapsulated in a very, very robust way, right? So it's not like it's some magic and you need to start worrying yourself. Then we have gRPC communication. So gRPC, Google Remote Procedure Call, is just another way of communicating, doing inter-service communication. Now, for gRPC, it's a bit complex to implement, right? It's just use proto files. It's just like what you're doing is just like creating a fragment of how would I put it? Maybe the service you are trying. If you guys have used, I'm trying to find a way that will be easy. If you have used SOAP, for maybe guys that have worked in banks here before, if you have done SOAP service before, where they will give you will import it, you connect your code to it, then it will now be as if you can even visualize some of the library of that service. That is, gRPC is similar to that. So, but there is always this argument about RESTful API and gRPC, which one is faster? To me, I don't even know. I wouldn't lie to you. I don't know which one is faster. I've only used gRPC once, but most times I'll prefer to go with RESTful and asynchronous. You could try it, explore, and see what benefits you get from gRPC. Then let's look at the next thing. We talk about data management. look, at the end of the day, it's all about data. You are managing a lot of data. You're managing user data, other data. It's a lot. If your data house is messed up, everything else is messed up, right? If something goes wrong, then you don't have an application anymore, right? Now, we need to make sure data is decentralized. Each services manages its own data, avoiding a single point of failure and reducing coupling. Remember, I said I would have liked to call an organization out, but I wouldn't do that. Now, this is the problem the organization is likely going to have. Now, they have multiple services depending on a single database, right? I've even been in a situation where I developed and the client was after our lives, that situation where you are trying to deliver value and the person you're able trying to deliver value for wants to kill you, So you cannot say you're building microservice, then you have one database. Everything is talking to your MySQL database. This one, MySQL, the same database, which means if anything goes wrong with that database, or maybe data corruption on your server, something happens, and to make matters worse, you don't have proper backup. Maybe your last backup was last month. What will happen to the recent data? You're in trouble, right? So you want to make sure that you have a decentralized data store. The one using MongoDB is there. The one using MySQL, Postgres, they stand alone. And you're only communicating through inter-service, not everything depending on one database. It doesn't make any sense at all. Then we talk about event sourcing. You can capture state changes as events. It's similar to what I explained in our synchronous communication, right? We talk about CQRS. CQRS is like a design pattern. If you're familiar with the concept of CQRS, it's just a way to make sure things are like, there's a separation between our query and command, right? Most of the times, right, be it MongoDB, be it relational, whatever it is, at the end of the day, we are reading from the database and we are writing to it, right? When you do a get by ID, get filter, whatever it is, puts, post, you are writing to the database, right? So we want a way whereby we can separate the function of the database. So this is like an advanced concept in system design, right? Where we have like a kind of, there are different ways you can go by it, right? Now, if you see in this diagram, you see there's a database that is saying write database, and we have a database saying read database. Now, the normal way some people do it is that when you are implementing CQRS, you use just one database, right? You read and write from the same database. But when it gets to advanced system design, we separate the database, which means that the one we are reading from is even different from the one we are writing from. So what we always do is make sure that we are syncing data, right? Whenever the write data gets updated, maybe at the end of, operation, it will sync the data to the read one. But the one that is meant for read, we don't even write, or, we don't change anything there. There's a reason why all of that is done. Well, let's focus on the command query. So this will deliver anything that has to do with command, deliver it to the UI, and this one, anything that has to do with get by ID, and deliver it to the client as well. Proceed. Now let's look at developing and deploying microservices. This will be the last part before we move to conclusion. Now, I mentioned about, not being constrained or confined to one framework or one programming language. You can use .NET for one service, use Nest.js for one service, and everybody is happy, all right? Then we also look at containers and orchestration. So now, I know I've been saying a lot. I haven't talked about how we manage our deployment. So when it comes to containers and orchestration, right, the first thing that comes to our mind is Docker. Now, if you're not familiar with the concept of Docker, I will explain using an analogy, right? Now, think of like the way you manage your deployment. When you are hosting your code, maybe on any infrastructure, sometimes we ask you, okay, you guys, if you have experienced this kind of situation whereby maybe you developed an application is using the latest Node.js, right? Then, if you are familiar with all these old, what they call them, if you're all these website developer, you do WordPress and the likes, So if you want to deploy to, I'm trying to remember this deployment service, they will tell you what they have is Node.js 14. So if you have like Node.js 17, for example, you won't be able to deploy because your subscription does not cover, you begin to handle what does and all of those nonsense, right? Now, even on cloud, sometimes you face those issues, right? Where you need to make sure you meet up with some requirements for your deployment. Oh, you need to have Node.js this, you need to have NPM this. Oh, this package is not, it really depends on what kind of subscription you're on. Now, why do we have Docker? For Docker, you don't need to worry about, think about a container that kind of like wrap up your code and ship it off for you. It ships it anywhere, you run it anywhere. Now, sorry, if I explain the concept of Docker, right? One thing I shouldn't miss is the constraint of whether you're on a Windows machine and this and that. Some applications can run on Windows, some can only run on, maybe Linux and the rest of them. You don't have that constraint. Now, Docker does not care what you have developed with. It packages your code, wrap everything up, and run it like a container. So all you need to deploy is your container. So now you're not saying, oh, I need to deploy my .NET. Where can I host my .NET application? Oh, I need to deploy my Node.js application. All of that, you don't need to worry about that. Once Docker wraps it up, deploy it anywhere and run it anywhere. And the beautiful thing about Docker is you can have multiple instances of it, right? You can have multiple instances of your application. But for Docker, it's easier with containers, right? You just duplicate this container and everything is running fine. Now, if you look at this, right, you see we have shopping clients, we have shopping API. Even for our front end, right, we Dockerize it as well, right? It doesn't matter. Just wrap everything up. I worked on a client application and it was using on-prem server. So we Dockerized everything, even though everything was built on .NET. Now, the beauty of that was that the deployment process was easily automated, right? Because now that we are on the on-prem server, all we just had to do was set up some GitHub actions, drop the container, recreate the container based on changes, all of those fun stuff, right? So Docker just has a way of making your life easy as a developer. You can go to their documentation, you will understand it. You can even like Dockerize your database, right? Which is like another beautiful thing. Database hosting, you guys will agree with me, like it's a lot of headache. It's a lot. It's a massive, massive headache. So you can Dockerize your database too and just deploy it. You don't have to worry about, MS SQL. Where will I put it? My SQL? No, you don't need to worry about all of those. But, setting it up might be a little bit technical, but once you get comfortable with it, well, there's so much to enjoy there. Oh, I didn't talk about Kubernetes. So Kubernetes is just like an orchestration, right? If you begin to work with cloud or you've been working with cloud, AWS, Azure, you would familiar. Now, the main purpose of Kubernetes is that as your microservice grow, especially when you're having multiple instances of each services, it becomes really difficult to manage. So Kubernetes can help you with that, right? Don't worry, this call is not for Kubernetes, before I confuse you guys. Now, we have CI/CD, which I mentioned earlier. Now, with CI/CD, you can automate, build, test, and your deployment process. You can set up everything with Jenkins, GitLab CI, and the rest of them, right? Now, the whole thing we are talking about here is still microservice. Now, why we are saying CI/CD? It's easier when you are managing one application. You deploy, the old way of doing it. You just wrap up the code, publish, or you even download the file as a zip. Those crazy things. Wrap it up as a zip file, upload it as a zip file, or if you have like all these basic deployment platform where you can just send the code directly, it's just nasty. But think of a way whereby you have like a branch. You have your main branch or master branch. You could call it deployment branch. You have your development branch. You have everything. Now, the senior developer or the lead engineer, you guys have done your pull request. You have reviewed. Everything is fine. we are working on, let's say, product service. Everybody has done what they need to do. The code has been tested. Now, you guys might have rules that says, okay, you can even configure it on your GitHub or whatnot. You can say this thing must pass all pull requests. It must be accepted before it can be merged to this branch, right? If it doesn't fulfill the requirement, it's not going to be merged, right? Now, so we can assume that before we merge all our code into one branch, it means the code is excellent and ready for deployment, right? So if it's ready for deployment and we merge to the branch, why do we need to merge to the branch and still go and deploy the code again? It doesn't make sense. So what we do is just use CI/CD. Once it passes all of that phase, automatically, once the code builds on the deployment branch, it will automate and deploy to the this thing. So you don't need to worry about deployment problems. Oh, what do we need to do? Oh, somebody needs to deploy. Just merge to master or merge to deployment branch and you're good to go. I'm sure you guys must have seen things like Vercel. Vercel gives you CI/CD out of the box. You don't even need to set up anything. Or if you are the cloud guy, you might need to do some, CI/CD setup or Microsoft Azure. But it makes your life easy. You just focus on business value. Right? And that is what all these technologies are trying to help us with, to make sure that we are able to deliver value to customer as quick as possible. So you see the stages here: run your test, build your image, that's for your Docker. You run end-to-end tests, then you do your release. Now, there are cases where we call them jobs, right? For every deployment, it is a job. You have a YAML script running. You must have, sometimes if you're using Azure, Azure gives you YAML scripts. You don't need to write it yourself, right? If your Azure is connected to your GitHub, once you do the connection, it will give you an artifact. You see the script, everything has been automated for you. But if you want something custom, maybe you want some criteria to be set, you might need to like alter the script yourself. So for every time a deployment happens, it is called a job, right? So you can see the status, it can fail. Maybe when you guys were merging the code to the deployment branch, the code was not building. We developers, sometimes we have the bad habit of not testing our code, build it to make sure this thing is running. We just, push it. Because of that, your deployment job can fail, right? Then when it's successful, everybody's happy. You see your changes in your deployment. Then let's look at testing. Okay, I mentioned before, as a developer, see, when you're developing, right, there's no excuse, especially when it's microservice. You need to do a lot of unit testing, right? This will ensure that your individual components of a service, everything is working. You can also do integration test. Integration test is when, now units mostly use mock services, right? You're just like testing each unit of your service. But for integration test, you are doing like straight connection to your database to see if everything is working as they're supposed to. Whatever works for you, right? Just make sure whatever it is you're doing, you do it well. It's very, very important. Test your microservice, right? Because especially when you're looking at inter-service communication, even though we have mentioned they are not dependent on each other, we also need to consider the fact that they are going to communicate with each other. So when one service is down and another service is relying on it for communication, it will still be a problem, right? But the beautiful thing about microservices, each of the services they have their own operations. I won't say, oh, because something is wrong with payment service, now the whole of my e-commerce application needs to go down. It doesn't make sense. So even if my payment service is not working, people can still go on my platform, check my product out, add to basket, and do whatnot, right? They could even try to process payments, right? Maybe when they process payment, we send it to a queue. Maybe the thing will just show pending. By the time whatever it is that is impacting the payment service is resolved, it could take like 10 minutes. You must have experienced something like that. When you make payment and it's showing pending, it's just because there is a problem with that service. By the time the service is good again, then you get a notification that your payment was successful. Microservices is really, really good, but every good thing has its own problems. We have the challenge of cost. We are saying, oh, have this database, have that database. Now, when I said I wanted to call some organizations out, these are some of the things they consider too. How much is it going to cost us build this database? Hosting and managing all of that is a lot of money, right? But if the organization has the capacity, for example, now the likes of Jumia cannot be complaining about, they know how many customers they are serving. They know how many requests they get. So the important thing is you should know at which stage you need to introduce microservice. You don't just introduce microservice because you like the concept or you feel it's not like design pattern. All right. It's an architecture for enterprise. So if your business is not enterprise, maybe it's a small business, right? You don't want to start developing microservice and put yourself into a lot of constraints. The management of microservices is already a lot, So make sure that you consider everything before you even talk about microservice. So yeah, we come to our conclusion. I know there's a lot that was not said. I would have liked to, take us a deep dive as to how can we develop microservice. Hearing is one thing, but being able to I know what you guys might be doing now is just you're trying to conceptualize it, trying to frame it in your head. Okay, what is it going to look like? I would have liked to showcase, okay, see how you go from point one. This is how you spin up a new instance. This is how you do this and do that. But I'm sorry, 2 hours will be enough for that. So yeah, our conclusion, just like I said, the final thoughts, emphasize the importance of a well thought out strategy when transitioning to microservices. Sometimes we move from monolith to microservice. Sometimes we just develop the microservice. So when you're moving, that is why one thing I always say is, no matter what you are doing, even if it's a monolith application, do it very well. Have separation of concern. Adopt a design pattern, because imagine moving from a monolith application to a microservice and all your code. I've seen a controller, everything in the application is using one controller. When you work on some applications as an engineer, you can even fall depressed, like, what is this, for God's sake? So imagine trying to transition something like that to microservice when you don't even have services separate. There's no sort of architecture at all. You can't even say this is this service, this is that service. There's nothing like that. So, and also your repository. Now, if you're moving to a microservice, you don't have a repository and infrastructure layer. You go to your service, you do database connection.open. You go to another method, database connection.open. That's nonsensical. But if you have done an abstraction of your infrastructure where your code is connected to database, right? You've done your separation of concern. Service does not need to know about how you are inserting, removing, updating your database. It's just focused on your business logic. Now, if you don't do all of that, you'll find it difficult moving to a microservice, because now, when you move to microservice, some services will probably need to use another data store. Now, you have written code now, you are instantiating your SQL connection in your controller. How do you want to do it when you're moving to microservice now? You need to use MongoDB. That means you need to refactor the whole code. So that one, you cannot even say you are transitioning, you are rebuilding because there's nothing to transition to. So when you adopt proper design pattern, right, you follow object-oriented programming the way they have told you to, your life will be easy. And for example, this was one thing we achieved at InterSwitch when we were moving quick teller homes. The way the thing was built, it was good. It was separated. So we're just moving the functional components into different services. But, when you I've even seen a case whereby I showed an engineer something when a client was saying, this code is something, the engineer said, this is over engineering. My brother and sisters, there's nothing like over engineering. Do it excellently well. That's what I believe in. There's nothing like, if you can't do it well, what's the purpose? There's nothing like scaling too fast. When they assign you something, right, think of the best way you can do it. And for me, even if it's you need a code to maybe help you alter how a date works. It should be separated. You can have like a helper service for that. Don't just, reusable code is there for a reason, right? The whole concept of design pattern, there's a reason. It's not just to show off. When you explain this to some engineers, sometimes they make you feel like, oh, maybe you are showing flexing muscle. It's not really about that. It's going to save you a lot, and it's going to save your business. You cannot say, oh, the business is small now, it's not very big. You don't know what might happen tomorrow, except maybe you are not thinking about growth. But whatever business you're doing, code is important. That is what separates you from being a developer to being an engineer. As an engineer, you need to think about system design and architecture a lot. And I always say one thing to engineers: you are saying, oh, you can write this code, you are the code master. I don't learn code. I don't focus on code. It's an absolute waste of time. Because look at what we have now. We have ChatGPT, we have Claude. Now, do you think somebody is going to hire you because you can write what ChatGPT will write for me? It will take you like 5 hours to write. ChatGPT will write it in 1 minute. Why should I hire you? What we are looking for now is how you think, system design, patterns, and how you are going to help our business. What businesses are looking for is value. They are not looking for developers. Right. So if you used to think like a programmer, well, I'm sorry, you want to learn Golang, you want to learn this and that. I mean, it's a whole lot. Before you wake up tomorrow, you'll probably introduce another programming language. Then people begin to panic. I need to learn this programming language. I must have job. I don't want to know. Learn problem solving, deliver value as much as you can. Then that way, you get what you want from, whatever it is you've been doing in your career. So let's make sure we follow through everything that has been said here, and you have a good microservice at the end of the day. Then I think that brings us to the end. Thank you. I've said a lot. So I'll give room for questions now.
Oh, thank you. That's quite a, I don't know. I'm not a software engineer, software developer, so I was just looking and listening from, but I'm sure the software developers in the house learned a lot. I mean, that was quite a set one. So loaded. Thank you, Abib. So we'll just take a couple of questions so that we can. All right, you know the way we do it now. Just give a raise of hand if you want to use the microphone. I'll give you speaking rights. And if you cannot use your microphone, just drop the questions in the Q&A box so that I read it out to Abib. All right, okay. Thank you, Stella. Thank you, Chidima. I said it was a lot. Quite a. All right, so if you have a question, just give a raise of hands. Thank you, Millicent. Nice to see you here. Oh yeah, I have questions, so please. Okay, maybe Habib, I think you mentioned something about a deep dive, like maybe a practical session or something. I think it's something we can look forward to another time, right? So that we can put all of these theories into some practice. Okay, so please use the Q&A, you can use the microphone, and please let's ask questions. It wouldn't make sense that someone spoke for close to an hour, 40 minutes, and we just have to let him go like that. Please just let's ask questions. Hi to the man.
Hi, can you hear me?
Yes, please. I can hear you.
Okay. Thank you so much, Habib. The session was really insightful. So, for me, I want to ask, what's the future of microservices for the front end? Do you foresee a massive adoption just like it is for the back end now? Yeah, that's my question. Thank you.
That's a very good question. So, like I mentioned, at the end of the day, it's all about business needs, right? And even though there are many ways you can design microservices, different businesses have different requirements. I did mention of an example where some businesses just want to be like constrained to only one database. even though that's not like the standard way. So it really depends on the business goals. For some businesses, for example, if you have like a very big business, right? There's something I want you to understand. We have something called SOA, service-oriented architecture. SOA sometimes looks like microservice, but it's not. Now, I'll use that InterSwitch example. InterSwitch has the payment service, right? And they have different other products, but these are not microservices, even though they leverage their own products. So these are like separate services, right? Now, if you want to build service-oriented architecture, there are also like some parts you must take. But if you are like a big business and you don't want to have separate products like, InterSwitch does, InterSwitch payments, this and that, you just want to have a single product, then you have your payment service. In your payment service, if a lot is going on there, it won't make sense you are using the same code base for, the other service you have at the moment. It will not make sense. If in your payment service, people can do this, they can do that, then that's going to create a lot of problem. If you think from a developer's point of view, right? I've seen a lot of messy code, right? Especially if you are somebody who writes React. When you are using things like use effects, where you'll be having like what's it called? Recursive call on APIs, it can get really, really nasty. In fact, you can have deployment issues because you are putting everything in one code base, your code will be extremely large. And because of that, it slows down deployment time. All right. But if your payment is just one single page, why do you need another microservice for front end? But if your payment is heavy, it makes sense. You can have like another domain for your payments and you have people that are focused on it. So it really depends on the business need, and it's very, very possible.
Okay, thank you very much. Thank you.
All right. Hi, Chidma. I hope that answers your question. Okay. So while we're trying to take more questions, I'm trying to share the link to Abib's Medium. You're going to find a lot of helpful stuff there. See. All right. So we have a question in Q&A. Someone says, okay, thanks a lot, Mr. Abib. The class was very insightful. Please, is system design a whole different tech track? How do I incorporate it as a beginner in backend development?
Okay. So you see, the concept of system design is very, very broad. All right. So when we talk about system design, we're not really talking about one thing. It's a concept in the real sense, right? So everything you do from basic to advanced, you are designing a system, all right? But for each system, it requires different architecture. Okay. Now, when you get to that advanced stage, that is when you begin to like, understand or learn a lot of concepts like database sharding. In fact, I did make an example. I said, when you see the likes of Netflix use architecture, you begin to tell yourself that no, this one is something else. That is why if you have been privileged to do their interview before, it will be basically system design. Why? Because they are thinking of what you understand in terms of data structure, scaling an application. You cannot go to Netflix and be thinking the way you are developing. It's a different ball game entirely. So to them, it's called system design, right? How they can even ask you questions like, imagine you want to build an application that will serve 1 billion users. How will you structure the database? Those are the kind of things they will ask you. So the main purpose of asking the question is they are not saying, oh, you should design. They want to see how you will manage the application to serve that large number of users. Then you begin to talk about, okay, some concepts you introduce, maybe you use like a kind of database, how you duplicate or replicate all this load balancing. I mentioned database sharding. Imagine you have like an SQL database, and in your SQL database, you have like 10 millions of records. Before you do a search in 10 million of records, that's definitely going to like slow your operation time. And if you're not doing like a lot of joins and all of that, it's going to cause a lot of problems. So it's like a different ballgame entirely. But why we don't say it at this time is because we just see, well, everything we are doing now is like something that is very straightforward, just build this. The only thing it wants you to worry about database API. You're not like the CTO. You're not the one designing the architecture. You're not the one worrying about the business concern. What is going to happen when we have 10,000, 50,000? How you are monitoring the progress of your application? When your application goes down, what is the strategy you have put in place? These are some of the things that come under the core of system design. So you can look through Google. I can say another question. You can check Google. You see a lot, right? But one thing that I feel is very important is sometimes we get carried away easily. We want to know everything, but follow it step by step. There are some things that if you don't understand, when you see system design, you just have a headache because you cannot even relate to what they are talking about. But yeah, take it step by step. Understand some basic concepts like microservices, design patterns. When you do, then see if you can begin to like get yourself familiar with system design. But it's just a lot of architecture and understanding how things connect.
Right, that's fine. Thank you. I hope that answers your question. All right. Okay, Daniela asks that which platform can we learn system design? Is there like a platform to learn?
I did mention that for system design, there are a lot of videos you can find on YouTube from maybe people that have worked in Google, Amazon. They've done a lot of video. You would see a whole lot of them. You see, just type system design, go to YouTube, you'll see a lot of it. There are even some dedicated professional courses you can take. For one, I don't worry about all of those things. But one thing I feel is very important is you start from small. Just build yourself. Don't be in a rush to learn about system design. Trust me, there is limit to what I know, right? I don't know everything about systems. In fact, I think I've only been in a system design interview once before. It was for a Lithuania company. And I don't know what's wrong with my alarm. So it was for a Lithuania company, and they told me to start drawing the architecture, the load balancer, how everything will connect, a lot of advanced things. And it was really, really crazy. So don't worry about it for now. Just take it one step at a time. Then you get there. I don't, except maybe you are trying to make an application through to Google or Amazon. Then you even see system design interview. Those will speed you up. But trust, it's not something you should worry about now.
Thank you for that. Beautiful. Hi, Daniela. That answers. I hope Abib has been able to answer your question. All right. So please, we'll take a couple more questions before we call it a wrap. I can't find any question in the Q&A aside from one, and nobody is raising their hand. Okay, should I take it as we haven't learned anything today? And I really don't think that is so good. The only way we can appreciate Abib and make him understand that he has done some teaching is to ask questions and get clarification, right? So I'm waiting for the questions. If you want to use the mic, it's fine. Just give a read the mic. And you can use the Q&A session. If you want to, if you cannot use the mic. All right, so who's going next? Barakad, do you want to come to Abi? Ibere. Yeah, now, please do ask questions. After this one, I don't know when next I'll bring Abi, even though I'm trying to see if it can come again to put some of this theory into practice, and then we'll see how it works. I hope Abi will be able to do that for us. Right? Would that be fine?
Enough questions. Not sure.
Okay, we are not. Have you said he's not sure we come since you guys are not asking questions?
Questions.
So please, though, please ask questions. Anonymous. I think we've had a conversation again that we don't want to be doing anonymous here. I want to be very sure that we are all humans on this call. There is no AI here. So don't be shy to ask questions about put your name with your full chest. There is no knowledge wasted and nobody's going to castigate you for asking questions. So I'll give you the rethink. Anonymous people, please put your name now. I'll check. I'll check the chat box if we have a question, and I'll go back to see if our AIs have turned to human beings. Okay. All right. Someone said I need more clarification on how I can leverage system service as a beginner in cybersecurity. In, okay. I mean, do you want to take that?
So,
I do.
I think this person mentioned they were not on the call earlier. So the call is
Yeah.
it's actually about microservice, not really system design. However, I'm not a cybersecurity person. I don't know if system design is something they adopt heavily on there, but I'm sure a lot of YouTube resource, or maybe next time I could research for you. But if it's about cybersecurity, I'm sorry, it will be hard for me to give you any reasonable answer there.
Success, I hope your question has been answered because I know we're speaking about software developers here. Hi, Olabamuchi. Yes, the recording will be shared after the session, and the slide will be included in the recording, so you don't have to worry about. Okay. Selima is asking, can you help me talk about MVC frameworks and which one is good?
I'm not sure I
Is
understand.
that something we talked about on this call? Yeah, I'm not sure to ask about. Can you help me talk about MVC framework? Which one is good?
MVC framework, which one compared to what? Okay.
I'm not sure what that means. Hi, Selima. You might want to use your microphone. Maybe you can explain better what your question is. I'm not exactly sure. All right, I would like to take it as there are no more questions because the Q&A is empty and nobody is wanting to raise their hand, and I don't think that is nice enough. Abiba said he will not come back if there are no questions, except you don't want him back again, but I'm sure it will be very helpful and it's very insightful if we can put a practice to this session. But regardless, I'm not going to look at your behavior. Your behavior today. I mean, we just figure out something about a second session, how we can see how we can have like a practice session for today's um today's conversation, if that would be fine. All right, so okay. Hi, Paul.
Hi, Khadija.
I
Okay, so I mean, thank you, Habib, and it's been a great session. My name is Paul. I'm Khadija's colleague. Super amazing to have you here, and in advance, you can be sure that we'll be coming back, maybe for something very much different. But I was just thinking, maybe we can give Salima, that's Salima, who asked about MVC framework, and maybe you can allow her speak through the mic. If she can give context, it might not be something that Habib may have to speak to here. I'm sure that Habib will welcome connections with him, so that if it's something that I don't think is related to what we learned today, but if it's something that Habib might be able to give some content around, he can definitely, maybe give an opportunity to engage him on a different platform from here to just provide insight for her. So, Salima, I believe you are still on the call. Just in case, and if you don't have context, that's fine. But I just thought to make that comment. Hi, Salima.
still on the call.
Hi, Salima. Are you there? Can you talk to
Yes,
us?
I'm here. Yeah, good afternoon.
Good afternoon. How are you doing today?
I'm good. How are you?
Okay, I'm fine myself. What country are you from, please, Salima?
I'm from South Sudan.
Oh, South Sudan. Ah, that's great.
Yeah.
That's great. Okay, so your question, would you like to, are you practicing as a developer already, or you are newly transitioned as a developer?
I'm actually practicing as a developer, and my question was actually there are some frameworks which we used to learn about, we used to practice on. Like there's one called Code Igniter. I don't know if you know anything about that. I'm sure you know. That is what I was actually talking about. So I was just asking which one is better because I hear now that there are now too many in the market, and I'm just getting confused. That was what I was asking about. Thank you.
Okay, so very quickly before I hand over to Habib, so you were trying to compare frameworks, is that it?
Yes, actually, frameworks.
Okay, so are you
And like
since you are practicing, are you front end? Do you do front end or back end, or do you do full stack like Habib?
I am a full stack developer actually, but I
Okay.
major mostly in a back end.
Yeah, okay, that's for me. Backend is the closest cousin to full stack, so it's understandable. So I
Yeah.
don't know if Abib can take a few. If it's something you don't want to engage, yeah, that's fine.
Yeah.
Sure she can connect with you. We can share your LinkedIn profile so that she can connect with you and engage you afterwards. But if you can just give a few comments around frameworks and then respond to, since there are lots of them and there will still be plenty of them, which one is preferable? How do you ensure that you are versed with the ones that are relevant to whatever you do in your.
Okay. All right. Thank you very much. So why I didn't even respond to that initially was the question itself is confusing, and now that Sadima spoke, it's even more confusing. But I would try to see if I get what she's saying. Now, Sadima, when you say MVC, first the MVC is not a framework. I know a lot of times we hear the MVC framework. That's not what they're really talking about, right? It's a kind of architecture, call it model view controller, right? And it's not under the purview of microservice, okay? But when you're talking about MVC, it's just a way to, remember I mentioned about separation of concern when you're designing your application, right? So what we are doing is like a kind of domain-driven architecture where you make sure your models are separate from the layer of your views and controllers, right? But it's not really what we are looking at here. Now, when you're talking about frameworks, you mentioned about Code Igniter and the rest. There are a lot of frameworks, right? I'm not sure what programming language you're talking about, but I'm thinking you are a PHP person, right? Now, if you do
Yeah.
PHP, if you're looking at the best framework, one thing I always like to think is there's nothing like best, right? It's just based on what you need. But one thing all PHP developers will agree with is Laravel is like the best thing to go with now. And if you are using Laravel, of course you have to use MVC, right? You need to separate your model, view, and controller. So don't mix it up. When you're talking about framework, you are talking about um, what you a kind of library you can leverage where all of those abstraction you need to get your development going is done, right? You have the likes of Code Igniter, like you said. We have Laravel for JavaScript developers. We have Node.js, Express, Nest, and the rest of them, right? So don't mix it up, right? MVC is just like a simple architecture. It has nothing to do with frameworks. So if you're looking for the best framework, Laravel will be your go-to framework. I hope that helps.
Yeah, thank you.
Thank you for the context, Abib. Salima, I hope you have more clarification now. Okay. I think we don't have any more questions. If you are here, we still have about 2 minutes to go. If you still want to ask a question, please, you can do that now. Just give a rate of and I'll give you speaking right. Well, in the absence of no hands, I'll take you that we don't have any. All right. So I hope we'll be able to, after this session, we'll be able to incorporate the use of microservices into software development. I'll also try to see if I can have a conversation again with Habib, and then we'll see how we can have a practice session. I think we did mostly theory today. We'll see how we can have a practice session so that we can have insights into how we can really use microservices. All right, so that'll be it. And please, let's go to LinkedIn, just like we usually do it. Share your learnings on LinkedIn. Just write something about what you've learned today. Tag Abib. I dropped his profile in the chat box. Tag Abib, tag myself. Tag Tech for Dev so that we can see what. All right, so that we can see that okay, we're doing something really good. And yes, so I have the link to Abib's Medium too in the Abib. Can you please put the link? I was told that the link I dropped is not responding. I don't know if it's just her or it's
Let me see if
general.
I real quick.
If you just drop the link to your Medium. Okay. All right, so I would like to bring this session to an end real quick. I just want to say thank you to Abib. Thank you for responding within a very short notice. The link is to all panelists. Abib,
Yeah.
the link you shared is to all panelists. It's just me, Paul, and yourself that will be saying it.
Oh, wow.
Yeah,
Okay.
you need to share it to everyone.
All right.
All right. Okay, so Abib has dropped in. Yeah. So just do well to share your learning, some of the things you've learned, also what you'll be looking forward to again. And all right, Abib, everyone is saying thank you to you in the chat board. Thank you for following, thank you for sparing your time to take us through this amazing learning journey. I'd like to say thank you to you on behalf of Tech for Dev. Really appreciate, and I hope that very soon we can do something again on this particular topic, or maybe another one even later. So thank you so much, everyone that joined this call today. It's an honor having you on this. Thank you, Baraka. Thank you. I can see one Rukaya. Habib are you related?
That's the
That's the sister, right? Immediately I saw the surname, I'm like, okay, Viva's brothers. That's fine. So thank you, Uraola. Thank you, Bachu. Thank you, Success. Thank you, Rukaya. Thank you, Ramla. Olabamiji. Thank you too. Thank you for showing up for Abi. Thank you, Muslima. Thank you, all of you, for coming to this call again. See you next time on another upskilling session. Right?
nice.
Bye. Bye, guys. Thank you, Abi.
Thanks.
Do enjoy the rest of your weekend. Bye, Uraola. Thank you, Agnes. Bye. Thank you, Ramlas. See you next time. Bye. Bye, Mary.